Okay, so to reiterate what I was saying in the last segment, and apparently accidentally turned off my microphone, ha ha ha, is that um, the cyber vetting process is being used in ways that we innocently think we can get around by having fake Facebook pages or unlisted things. Um, a lot of companies that have sensitive information or who are really concerned about their reputation, things like that, are going the route that the military used to take. When my husband was going for a top secret clearance when he was a Coast Guard rescue swimmer, he was asked to provide the names of 10 people who knew him who could tell details about him. And then when the officials came out and interviewed those 10 people were each asked to provide the names of 3 more people who they knew my husband, and so on. And by the time this interrogation process got done, over 100 people were interviewed, and that information was used to determine whether my husband should get top secret clearance or not. Now, a lot of companies don't have the kind of wherewithal that the military has to send out, investigators, but it doesn't take a lot of work to do the search of the internet to find things that you might be connected to. And so when we warn our teenagers, watch out what you're posting. Don't put pictures up on Facebook that you wouldn't want a future employer or even a school. Some schools have started doing this. So cyber vetting has become a really recent, and very important trend, and something that future employees and, future college students need to be aware of. Now, on the positive side, this use of social media to broaden the applicant pool has been a great boon for employers, because they can put out an ad through Facebook and it gets spread around really fast. And so that really has expanded their applicant pool. And from an employer standpoint, more is better. All right, so now we've talked a little bit about what a selection battery is, and how important it is to get a good pool of people in to take the battery. Now let's, in this segment, talk about how do we know whether it's a valid measure of whatever we're trying to measure, presumably performance on the job. So we can do a validation study, which is a study that is striving to determine the extent to which a predictor is related to a criterion. So the extent to which this measure predicts job performance, for example. We could do predictive validity tests, concurrent validity tests, and then we could do cross-validation. So we'll address each of those. And then we'll wind up in this segment talking about validity generalization, whether validity extends to other situations beyond specifically the job that you were interviewing for, being tested for. Okay, so let's go ahead and start with predictive validity. Okay, so with predictive validity, we're going to investigate how effective predictors are at forecasting the applicant's job performance. So it really, when you think about a predictor, this is probably what you're thinking of, how well it will actually predict your performance on the job. So we've got your predictor, and we're going to gather whatever predictor data we have for all the different applicants. So if you've got a battery that includes a general cognitive ability test and a speed test of some sort, and then maybe a psychomotor test, and everybody takes that battery, that set of predictors. Then you hire some of the applicants, obviously, hopefully some of the people who perform those tasks will meet your criteria, and you hire them. Then, after they've been on the job, is when you're actually going to collect the criteria data, which is what we're going to compare the predictor to. So you hire some of them, they do their job for a while, and then you analyze that performance data, and you calculate a validity coefficient. Anytime you see that word coefficient, you're talking about some number that is created by some multiplying and some dividing, right? So like correlation coefficient and so on. So the validity coefficient is basically going to be the correlation between the predictor score and the criterion score. Ideally, we're going to have a nice high number, something closer to 1. than to 0 between the score that you got on the predictor and the score that you got on the criterion once you've been on the job. If we've got a good predictor that can validly predict your performance on the job, we should see a good, strong, this is no psychology study, right, where we'd be happy with a 0.3. We'd be looking in this case for like a 0.75, 0.8, something like that would not be out of line. If we've got a good, valid predictor, it should adequately predict the criterion variable. Okay. Concurrent validation is a little easier to do. Therefore, it's more viable than the predictive validity studies. Because in the predictive validity studies, you saw that little criterion where you have to hire the participants, the applicants, and then see how they end up doing. With concurrent validation, we're going to try and sort of do everything all at one time. So in step 1, we're going to do the predictor and the criterion. So we collect information from people who have the jobs right now. And we're going to see whether their performance on our predictor that we want to use on applicants correlates with their performance on the criterion variable that we would normally in a prediction study would wait till they'd been on the job for some amount of time and see how they do. So we administer the predictor and the criterion together to people who currently have the job. And again, we want that validity coefficient to be a good high number, something probably over 0.75 in order to feel like the predictor is doing a good job of predicting the criterion. This is, like I said, easier to do because we don't have to hire some people who potentially are going to not work out. This is one way to establish the validity of the predictor without having to go through the risk of hiring new people who maybe the predictor's not doing a good job of predicting for. Now with cross-validation, we apply the same predictors and criteria to a different sample. What we're looking for here is to see whether the predictor maintains its predictive power even across different samples. This is designed to assess what we call validity shrinkage. Shrinkage is never good, whether we're talking about sweaters or we're talking about having been in the pool or we're talking about validity. We don't want the power of the predictor to be lost if you use it on different samples. Like if it's only predictive in this particular group, it's really not predicting. So, in this case, we calculate the predicted score for the current sample. So the predicted score for the current sample from a regression equation from a first sample. So you administer the predictor to a group of people who maybe are going through either the predictive validity validation study or a concurrent validation study. And you've got the pattern of scores, and then you've got the criterion variable for those samples who you did the actual other study on, either the predictive validity study or the concurrent validity study. So you've got the outcome for them. You've got a nice, I'm making gestures, I know you guys can't see me, but you've got that scatter plot line that we talked about, I think the second week of school, when we talked about the regression line and how if you know the score on one thing, you should be able to go up to the regression line and go over to the y-axis and find what score they should have on the other variable. That's what I'm talking about here with this, the regression equation. So you've got that sample of people who you have the predictor and you have their criterion variable, so you know what the correlation coefficient is. Now you're going to calculate the predicted score for this sample using that regression line. So you know their score on the predictor, and then you estimate their score on the criterion using the regression line. Then, now in this cross-validation study, the next step is you wait and do the actual criterion after they've been on the job and things like that, like with the predictive validity study. You hire some of the people, and you administer the criterion after they've been on the jobs for some amount of time. And then you calculate that correlation coefficient that I mentioned in the previous two examples to see whether the predicted score correlates with the criterion score. Here's where this is different and new. Now we want to see whether the regression score for the first sample and the regression score for the current sample match. So that what we're looking for is the consistency of the predictability. So ideally, these two R squares will match really well. Again, we're looking at a 0.75 or better correlation coefficient between these two R's. We want them to be virtually identical. And that way we can say, we can administer this set of predictors for any group of people. Maybe even we might want to argue across different contexts, and it still would be equally predictive. That's called cross-validation. We don't just use one sample to establish the validity of a study or of a battery. Smaller shrinkage is going to be better. So when we have these matching R squares, we have smaller shrinkage. The concern is that maybe you'll have a good strong 0.75, 0.8 in the first sample, and then when you use a different group of people, it's something less than that, 0.6 or something like that, and then you start to think, maybe this predictor is not that robust. Maybe it's not really doing a very good job of predicting the outcomes. Maybe there was just something lucky going on with the first sample, or something idiosyncratic, or something like that. The last thing I wanted to address in this segment is validity generalization, which is kind of what we're getting at with that cross-validation study. The idea here is we're going to use meta-analysis, not just a cross-validation study, but a meta-analysis, where we're going to look across validity coefficients across multiple situations. And we're going to weight them and combine them in this meta-analytical way, where you treat the different tests as if it was one big study. And we want to find out if basically, okay, so this set of tests or this battery was used in screening for applicants for IBM. And then it was also used by Microsoft. And then it was also used by Sun Microsystems. And it was also used by Corel. It was used by all these different companies. We want to average them together and look for consistencies across all these different applications of this battery. And the reason why you have to weight and combine the coefficients is that maybe when Microsoft applied it, they used 3 out of the 4 predictors that had been used by IBM. And then when Sun Microsystems did it, they used 3 out of the 4 plus a different one. And right, so that different companies may not have done the exact same battery, or maybe one aspect of the battery was slightly different. Maybe they all used an assessment center, but they didn't all use the same components in the assessment center. So you have to weight and combine these validity coefficients in a way to acknowledge that they weren't all an exact test of exactly the same predictors. But we want to look for good validity across all of them. We want the R's to pretty much match. Situational specificity refers to those situations where the test is really only valid in certain situations. It might be that it works for screening managerial applicants, or it's good for sales staff, or something like that, and not for other situations. It's pretty much expected that a battery is going to be job specific. That a battery that works for screening out managers is probably not going to work as well for laborers on a factory line, something like that. But it should be generalizable enough that it would work for managers in a corporate setting like an office versus managers in a sales staff position, or it should have enough robustness that it should be able to be applied across multiple situations. As we know, no test is ever going to work perfectly for every job. I mean, you're going to have to tailor to a certain extent, but we would expect at least some consistency. Okay, well, let's go ahead and stop here, and then I'll pick up with the practical approaches to selection in my next segment.